Our goal in this example is to graph this polynomial function, third-degree polynomial. So we're going to collect a bunch of information about this and then put that together into a nice graph. First piece of information we'd like to collect is the y-intercept. Now, the y-intercept always occurs whenever the x value is 0. So what we're going to do is we're going to replace each one of our x's in this function with zeros. So how this works out is it's going to be 0 minus 0 minus 0 plus 8, which works out pretty easily to be 8. So we have a y-intercept at 8. Next thing we'd like to know is what are our x-intercepts or zeros? So the x-intercepts or zeros are easiest to find if you have it in factored form. So what we're going to do in this one, because we have 4 terms, I'm first going to approach it by thinking factor by grouping, where I group the first 2 terms together and the last 2 terms together. Looking at the first 2 terms, they have a common factor of x squared. So that's first going to come out, and we're going to think to ourselves, x squared times x would give us the x cubed, and x squared times negative 2 would give us the negative 2x squared. Now, for factor by grouping to work, what's in that first set of parentheses also has to work out to be in the second set of parentheses. So in this case, what I'm going to go ahead and do is say we have to end up with an x minus 2 in that last set of parentheses for this to work, because that was in the first set. So I kind of work backwards, and I think x times what gives us negative 4x. That would have to be a negative 4. Now, if I did redistribute this and think negative 4 times x, negative 4x, negative 4 times negative 2 is going to be that positive 8. So it does work out how we had hoped. All right, to finish this up, what's out in front, the x squared minus 4 is going to go in one set. And then what's on the inside of our set of parentheses, the x minus 2, goes in our second set of parentheses. It's actually a common factor between those 2 multiplications. All right, we can factor one bit more by saying, well, we have x squared minus 4. That's 2 terms. That's a difference of squares that'll factor as x minus 2 and x plus 2. And then we'll bring along the x minus 2 from the end. So what we've done is we've split apart, we factored further the x squared minus 4 into x plus 2 and x minus 2. All right, but notice we do have 2 of the same factors. We have x minus 2. We have 2 copies of that, so I'm going to use an exponent of 2 there, and 1 copy of x plus 2. So that's raised to the first power. So I'm just copying it down below here, the factored version of the same thing. All right, next, let's pick out our zeros or x-intercepts. So what we're going to do on this is you want to look at the factors and pick out your x and say, what would I need to replace the x with here to make this first factor equal 0? Well, if I put a 2 in there, 2 minus 2 makes 0. So that gets positive 2 as being a 0 or x-intercept. And the second factor, if we replace that x with a negative 2, it would make negative 2 plus 2 equals 0. So those are our zeros or x-intercepts, or sometimes we refer to them as roots of our polynomial. All right, next, their multiplicities are going to come from what exponent each one of these factors is raised to. So the positive 2 for a 0 has a multiplicity of positive 2, and the negative 2 has an exponent of 1, so it has a multiplicity of 1. Now, as far as figuring out do they touch or cross, even multiplicities touch, and odd multiplicities cross. So the first one, we had an even multiplicity, so we'd say that one touches. And the 1, that's an odd number, so we'd say it crosses. All right, next piece of information let's pick out is the end behavior. Now, the end behavior is dictated by whatever the leading term is. So the leading term in this case is going to be the very, very first, because it's in descending order, the very first term of our polynomial. So we can say our end behavior is going to resemble whatever the graph of y equals x to the third power's end behavior resembles. So in that case, what we think is, well, it's an odd power function. Doesn't have a negative in front, so the tail on the right-hand side goes up, and the tail on the left-hand side goes down. Or we could say as x approaches positive infinity, that means going off to the right-hand side, our function has y values going up also towards positive infinity. On the left-hand side, we would say as x approaches negative infinity, that means going to the left, our y values go down. Well, negative infinity is thought to be down for our y values. All right, last thing, maximum number of turning points, and then we'll put this all together. It's always whatever the degree of the polynomial is, minus 1. So the degree of our polynomial, because it wasn't in the expanded form at the beginning, we can see the degree was 3. We subtract 1 away from that, and our maximum number of turning points, or the total number of maximums and minimums combined, is going to be 2. All right, let's try to put all this information together and get a nice graph going. All right, so the first thing I'm going to do is go ahead and place our y-intercept is at 8. We have a 0 at positive 2 and a 0 at negative 2. So those are x-intercepts or roots. I'm also going to go ahead and include our end behavior goes up to the right and down to the left. And now all we have to do is make sure it's smooth and continuous, so no sharp breaks, or sorry, no sharp corners and no gaps or breaks along the way. All right, so for our zeros, at negative 2 is actually the first. I'm going to trace in from the left-hand side coming up here. The first point I get to is going to be at negative 2. At negative 2, for this 0 or x-intercept, we said that it crosses. So we cross over the x-axis here, and then we have to hit the point on the y-axis at 8. So I'm going to go up here to 8. And then the next point we get to is at positive 2. So at positive 2, we said that it touches. So I'm going to come down here, touch the x-axis, and come back the same direction. And notice the only other place we have to get to is our end behavior has to go up and to the right at the end. Now let's think, did we get the right number of turning points? Or did we exceed our maximum number of turning points? So you get 1 turning point when you switch from increasing to decreasing at the top here. And then we have a minimum here at 2 where we switch from decreasing to increasing. So that's what we think of as a turning point, either a maximum or minimum. Now, as far as how high this point should be, I put it a little bit above 8. We knew it had to at least get to 8, but we didn't know exactly where that highest point is on our graph, the local maximum going on there. It's more of a calculus question instead of just graphing a polynomial question. So I hope this helps out.